All right, this class is about heat transfer. So the heat, we use a capital Q. And then the thermal energy, that's the energy that we deal with in this class for most of the time. We use U. And then, so in addition to thermal energy, there are also many forms of energy as well. So this video is trying to refresh some concepts of the different forms of energy. So for the heat Q, we have the units of joule, and also the energy itself, thermal energy also has the joule. So that's the units. They're same. And if the heat has been used to heat up a object, or it is released during the cooling of the object, then that will be calculated using the heat capacitance times the mass, and then times the delta T. That's the internal thermal energy has been changed by the Q. So based on the thermodynamics first law, the conservation of the energy itself, then we would say the change of the thermal energy that would equal to this equation. And then here I just want to mention the work. Work is another form of energy. It's basically the mechanical energy. It has the same units of joule. The work is defined, let's say if you have an object sitting on a surface, a block sitting on a surface, and then if you apply a force in one direction and move this object to another location, and the distance along the same direction of the force, let's say it is the space or displacement S, then the work would equal to the force times the distance of the movement. And then, in fact, if this force has been used continuously for this distance, that actually will change the kinetic energy or potential energy, or either the thermal energy. So basically, this work has to be converted into some form of energy. So in addition to the thermal energy U, sometimes if you don't have the friction, here, then for most of the time, this object will actually be moving faster and faster if you have this force. So the kinetic energy that would equal to half of the mass times the velocity square. And in addition to kinetic energy, there is the potential energy as well. And then most of the time when we say potential energy, actually it's gravitation. Gravitational potential energy. That is basically, let's say, if you have the object elevated to a certain height. So let's say if this is the surface, it can be the surface of the Earth or surface of anywhere, which can catch the object. And then if you have a object here, which is elevated to a height of h, then the delta potential energy, and if we define this potential energy here at this position equal to 0, or in other words, you say the z direction equal to 0, then the potential energy of the object will be very simple. It's the mass times the gravitational acceleration g times the height. And then the g is, of course, is 9.8 meter per square, or you can just say Newton per kilogram. And these are the kinetic energy related. And then another type of force, not mechanical force, actually there's the electrical force. So if you have a pair of parallel plate and you apply a voltage across these two parallel plates, let's say if you use plus and minus, then you form basically a capacitor. This capacitor has been charged with your battery that you applied. And then within this gap between the two parallel plates, it will form a uniform electrical field because it's parallel. And if you have a single charge, single particle, or single charge, or a particle with a charge on it, and then let's say if it has a single charge, which is the electron, and the electron, we know it's a negative charged. And then this particle will experience a force, and then this force equals to electrical force equals to the electrical field times the charge on that particle. And then the charge we use, unfortunately, we typically use a lowercase q for the charge here. And then let me just use the words instead of using charge times the electrical field. And the units, however, the charge units is a coulomb times the electrical field is the volt per meter. So the electrical field strength is defined by how much the difference between the two voltages of the two parallel plates, and also how far these parallel plates is separated apart. And then, the SI unit system would having everything consistent. So this actually is defined as 1 Newton. As you can imagine, this is how actually a volt is defined. Coulomb is defined in some other way. And then this is the force. And then as you can imagine, if we having this force on this particle to move this particle for a distance, let's say moving this particle from this position to this position, and then this will be the distance. The reason I having the arrow moving upwards is because the electron is negatively charged, so it's attracted by the positive charge. Therefore, it moves upward. You can always use another force to overcome the electrical force and to move the other side, to move the other direction as well. But anyway, so the work done by this electrical force would equals to the electrical force times the S. as you can see, the S would be canceling this per meter distance. So that the unit will be Coulomb volt. That actually would equal to Joule. And then if you pass a current, if you have a wire, let's say if you have a wire, and then you pass a current across it, and in order to pass this current, the voltage across the two ends is the delta V, or you simply say V, or V1 minus V2. Let's say if this is the V1, this is the V2, then the delta V. Then this, the heat will be generated by this current that will be same as the electrical energy that would equal to the current times the voltage times the time. The reason why it is because I times the T times the voltage, the first two item here is actually the charge. Because the current I is defined as how much charge it passes within a unit time. So therefore the charge equals to I times the T. So that's the heat that can be generated. So in this semester, we will see quite a few problems related to electrical heater or electrical cooler or refrigerator or these things, because the electricity can be correlated with the heat that we are dealing with. So again, the Q equals to the electrical energy, that is I, V, and T. And then power of the electrical power or any electrical appliance, the power of any electrical appliance would equals to I times V. So if you think about the power of your AC unit at your home, or the power of the microwave, or the power of your stove, Ranger, or anything, or even your hair dryer, those power actually is defined by the I times the V. And then the V is the electrical voltage in United States. In United States, it is about 110 volt in US. So you can estimate how much current your appliance will need. But in this class, for the problem that we deal with, and then we typically ask you to calculate the Q from the I and the V, or vice versa. And then in addition to that, we will introduce more or discuss more later. Another correlation is the electrical resistance. So electrical resistance. As a matter of fact, we will use it quite a lot to deal with the entire semester using this concept, not exactly same. But the electrical resistance is defined as the ratio between the voltage and the current for an electrical circuit. So let's say if you have a electrical wire or coil, and then you want to pass a current across this coil. Then in order to do that, you have to apply a voltage. And then only after you apply this voltage, you will get some current. And then of course, the higher the voltage you apply, the stronger the driving force is for the electrons to flow, then the higher the current. And then that ratio is the R. Sometimes we just use the V, or sometimes use the delta V. In theory, delta V is more accurate, but for many cases, people just ignore the delta V. But when we say V over R, the V is actually the delta V across the 2 points. And then if we remember this ratio resistance, then we actually can further change the V. As you can see, the V can be written as I times R, current times the resistance. So therefore, you can even combine the I together. That becomes I squared R. Or otherwise, you can change the I using this ratio to do that. And that actually will combine the V as V squared. So you can also write that way. Okay, so I just make these things as a background. I think these are background if you taken some high school physics or some physics classes. All right.